my screen. Okay.
Sure. Let me make you host, which is here.
Because I have this horribly wide screen that if I share my whole screen, it will
have the same issue. It's actually my least favorite part of my new monitor.
Well, I love the fact that Zoom, if I'm host, lets me actually share just a chunk of my screen. I'm trying to figure out why it's not actually. Let's see.
You are?
Yeah, I am.
You are host.
I'm still not seeing the share chunk. Well, okay. Well, so I'm going to just go ahead and share just to get the meeting moving here. I'm going to share just the slides. And go ahead and you can go ahead and start, Christopher. I'll advance the slides as we go until it's time for my demo, and then I'll figure out what to do then.
Okay. Well, thank you everyone for joining our Blockchain Commons Gordian meeting today. Blockchain Commons is a community focused on self-sovereign control of digital assets. We bring together stakeholders to collaboratively develop interoperable infrastructure. We're a neutral not-for-profit that enables people to control their own digital destiny. And in particular, today, we're going to be talking about a number of projects associated with Gordian Envelope and collaborative seed recovery. Go ahead. So last month, we had a discussion, well, July, we had a discussion about URs and animated QRs, which is one of our most successful standards. Thunder Biscuit shared some experiences with using URs. We had a LifeHash use case where Craig implemented LifeHash in Sparrow. We had a bit of discussion about self-sovereign identity and where that's going. Gordian Seed Tool had a release, which we're going to continue to talk about today, and beginning to try to standardize on collaborative seed recovery. Today, we're going to talk about IETF 117, which three of us here at the call today went to. Some results from that, one of which is that we have a number of changes that we'll be talking about. We're going to talk about attachments for envelopes, which will be used for a variety of different types of things. We also have a very specific requirement for output descriptors for seeds. I might more generically call it, what is the signing policy for various key elements. If you want to talk about it more in an abstract, of which in Bitcoin has a very specific signing policy, which is described in an output descriptor. Shannon did a major update to the developer web pages to make them more accessible and searchable, et cetera. Well, not so much searchable on the website, but properly indexed by Google and others. Ori is going to be talking about the YAML formatting for disclosing docs, and I'm intrigued with what that might have some synergy for some things we're working on in the fall. And then, of course, we have these Rust libraries in community review and would like to move that forward. So we're going to be talking about that all more today. Do you want to start off with DCBOR, Wolf?
Yeah, well, we actually participated in the CBOR working group meeting at ETF 117 in San Francisco, and got some very good feedback. There seems to be a lot of support for it within the working group. Then there's definitely an ongoing robust discussion in the working group about how deterministic CBOR should be structured. There seems to be a fairly reasonable consensus that some form of stronger determinism for CBOR is needed. The debate, seems to be focused on, how we structure this in kind of abstract layers, because, there's a section of the CBOR RFC 8949 which talks about how to do things deterministically, but it makes a lot of suggestions, and there's not much normative there. And so And so, when you say, we're doing deterministic CBOR, how do you conform with that? Well, we took a fairly kind of radical approach with DCBOR in terms of, doing what we call numerical reduction, which is where if you declare a numeric field, it could be floating point or integer, but it basically uses the minimal encoding with no loss. And this is something that is, I have found in all three implementations I've done of DCBOR so far in Rust, in Swift, and in TypeScript, to be really good at both the programming level, the API level, as well as much more deterministic at the encoding level. And so, my whole stack that we're using at Blockchain Commons is now using DCBOR. And DCBOR is CBOR. So, anything that writes or reads CBOR can read or write DCBOR, but a DCBOR specific codec, like I've written, is very strict about what it reads and writes. So the idea is to leave as little up to interpretation as possible at the encoder level, and then the protocols you create on top of that, like Gordian envelope and so on, also need to be strict if you want deterministic results. And of course, I'm sure many people watching this understand there's a lot of different use cases for determinism, and so we want to make it very easy to opt into that. Both at the DCBOR level, which can be used totally separately from Gordian envelope or with Gordian envelope. And we want the kind of benefits of this to be available throughout the stack, although it's not required that you be deterministic in what you do. We're trying to make it as easy as possible. So we got some really good feedback on that. We published our current version, our internet draft is version 5. We actually, for DCBOR, we're not using any specific IANA numbers, as I'll talk about in a moment. We actually were issued an IANA CBOR tag for Gordian envelope, though. So,
Before we go on to that topic, Ori, you were at a number of these meetings. How are you seeing DCBOR and CDE and the numeric reduction, whatever, as sort of someone external to the conversation?
Well, agree that there seems to be strong support for DCBOR. And there's only like a few kind of tough parts that are still remaining as I understood it. And they seem like they'll be worked out eventually. So I think it seems like it's on a great track from the outside.
It definitely addresses.
My hope is that eventually it would become an RFC, but that's down the road, and we're not in a hurry for that. Go ahead, Christopher.
Yeah, I think definitely. For some background here, for the last 2 decades, there's been a lot of work on the Jose frameworks, in particular JWT, where when you sign things, because it could not be canonicalized, you had to include the thing that you were signing with the signature. Because it might have an extra carriage return in it, or an extra 0 in in a integer field, or a .0 or whatever. So it'd be semantically the same, but not signed the same. And this has just caused no ends of problems in the W3C, and it was our hope that this would be solved with Jose, but even Jose packages, it's kind of a CBOR version of the Jose stack. So they do the same thing. And there are some workarounds and things of that nature that make it better, but we really hope to avoid that entire problem. And layer violations by looking at semantic layers to do ordering, which is a layer violation. So we think we've achieved that, and we're glad to see that DCBOR is moving forward. Any questions on DCBOR before we talk about envelope? Okay, go ahead, Wolf.
Yeah, so we've had a few iterations of breaking changes with envelope as we've gone through revisions. We got a lot of really good feedback at IETF 117. In particular, questions that sounded naive to me at first actually made me think, go back to the drawing board in a number of cases. So I definitely appreciate the feedback I got, even if I'm like, well, why would you ask that? Because, for example, we were originally requesting about 5 tag assignments from IANA. And when it became clear to me that at least the low numbered tags, which we were after, were not something that the CBOR expert would be likely to issue to us unless we made very good case to him. We thought, maybe there's other ways to represent these things in kind of more native CBOR with fewer tags. And so I did several iterations on that, and it turns out that now we have a smaller, more compact, just as expressive version of envelope, and all we need is 1 tag, which is 200. And so we issued a new version of both, our envelope implementation, and requested a single tag based on our latest internet draft, and we were issued it. So we have Gordian envelope is officially tag 200. And so anything you encounter in CBOR that's tag 200 is a Gordian envelope, and even it could be just a single integer inside, which would be a known value. And I'll talk a little bit about the how I broke it down, because part of how we got this through is I broke the Gordian envelope spec, which was kind of kitchen sink, everything including the kitchen sink, and broke it down to like the nice hardwood floors, and that's what's in the current draft. And then I broke out other things like encryption and compression and known values and stuff like that into separate spec docs that are controlled by us right now, and that the tags we'll be requesting for those in certain cases are very high numbered tags, because they don't need to be small, and that won't go through pretty much any scrutiny. We're just the first come first serve. So but you can use this minimal spec by itself. It's good for elision, for holder-based elision, and it has the full Merkle tree in it, and so it has the basic benefits of envelope without any of these extensions. And so if you want just that, you can actually make your codec even tinier for restricted environments. So that's actually, it's turned out to be a huge benefit, I think.
It also, I mean, it is natively also a triple store for all 3 major variants of that approach. So I think
absolutely, our assertions have assertions. Everything. If you're familiar with my previous talks on envelope, everything that was true about envelope in terms of its hierarchy, its structure, its positions is all the same. So metadata has metadata if you want.
So I'm hoping that envelope core, like these sorts DCBOR, especially in its new 1 tag form, will also be of interest to people to build on. And so we've kind of pulled out a lot of the more cryptographic things, the SSKR envelopes, various forms of compression, signed signatures, etc. So really the only crypto in the core envelope spec is SHA-256, and we've had a lot of discussions about well, what about crypto agility? And our answer is, well, we'll reserve another tag for Blake 3 or SHA 3 or whatever somebody needs when that is needed. But right now there's just too many problems when you have multiple kinds of hashes in a single tree that we want to try to avoid for now.
Our general approach has been to be rather opinionated about, for example, I've taken a lot of my cues from the was it libnocle and the libsodium, in terms of the cryptographic primitives and constructs, because in their case they're saying, as a working engineer, here's the best practice, walk ye there in it. And so we've kind of taken that approach with our compression, our encryption, our public key encryption. And these are all now extensions to the base envelope. And you could theoretically implement similar extensions that used completely different. We can also extend our extensions to allow more crypto agility later if it turns out to be necessary. For now, we think we've chosen very strong structures that are battle tested, but we're happy to talk about where this needs to go in the future. If you need to change the actual digest algorithm we're using, which is, as Christopher mentioned, SHA-56, then you're going to want to change that top level tag 200 to something else to identify it as an envelope that's not using that particular thing. That's the only thing that would require a change to the top level tag.
Corey, you were kind of around while the sausage was being made, and it was a little ugly at times. And then I don't know if you followed the subsequent changes and kind of, getting acceptance from the CBOR experts for the latest version. But as I recall, you were really endorsing, separating out some of the things, and even had an interest in one of those extensions. Do you want to share a little bit about what your thoughts from 117 was on that?
Sure. So like in general, when things get stuck in any larger group, it's good to try and separate the concerns so that the things that are not contentious can move at their appropriate speed, and things that are contentious can at least not be connected to things that aren't contentious. So I think, it sounded like that meeting was really successful on discovering those opportunities, and things have progressed. I guess I'm still trying to understand with Gordian, the CBOR sort of side of Gordian and the tagging structure piece, and what parts of that what parts of those building blocks are relevant to other sort of work areas where you can have a sort of common shared building block with, maybe there's something that looks like Gordian but only uses one part of Gordian, for example. And so I'm interested in, as things get split up, what are those opportunities? And part of that's related to what I came here to present or ask questions about. But I'm not, deeply following the changes as a result of the CBOR working group. I'm not a member of the CBOR working group at IETF.
Okay. Yeah, I think the biggest thing is that there's still a lot of people who are calling for various forms of triple store, whether or not it's the group you've been involved within the SCITT, the supply. What does it stand for again?
It's the SCIT working group at IETF. It's supply chain, security, integrity, and transparency. Trust and transparency.
Yeah.
I can't ever say exactly what it is. It's not only software. The working group can talk about other things in future working groups, but the current charter is focused only on securing software supply chains.
So there was definitely, some discussion about a need for being able to do a variety of stores in there, structured data, not necessarily triples, but this would basically, at the minimum level, if you just do the core envelope, allows for elision to be possible, so that things can be signed even if some of the data is elided, which I think is an important use case for SCIT. But I also feel like there's a lot of people. I mean, I've had one party approach me of going, hey, we don't want to use verifiable credentials because we're making a lot more claims, and not all the assertions are about the subject. So how do we do this? And I'm saying, hey, you could just do it, even without signing and all the other different types of things. You can do a really nicely formatted CBOR with library to support, your complex structured triple store, and it'll work. So we'll see if they dive into it more.
Yeah, so on the screen is the internet draft that we successfully got the 200 tag assigned for. And then I just want to quickly point out that over here on our research repo, we have a number of the newer ones, the 2023 series, where I've defined, for example, encrypted message as a separate entity that is just a CBOR entity. And then, for example, down here under Gordian envelope extension, symmetric encryption, this uses that CBOR entity and explains how to use it within the context of Gordian envelope and how to extend the codec so that it actually is integral to envelope in that case, and it has a high number tag here, which only applies to encrypted envelopes. And our implementations fully support these. So, but you don't need to support them to have an envelope, essentially. So this is an envelope containing an encrypted message, and here are the 4 fields of the message, using the IETF CHA-20 Polygon 305 structure. So I just want to point out that our research repo has all these extensions. Here's an encrypted message, a compressed message, what a known value is, including our current registry of known values. This is essentially a way of kind of using, taking some semantic URIs from different ontologies and replacing them with a single integer, essentially, mapping them to a single integer. And these were all originally part of our massive draft that we submitted, and all these things raised a lot of questions, which we think we have really good use cases for them, but it was much simpler just to kind of extract them out. So here's how you use known values with envelopes. Here's how you use symmetric encryption, compression, Gordian envelope attachments, which we'll be talking about in a minute, and then how you represent Bitcoin output descriptors. Some of these are extensions to the actual envelope format itself and require changes at the codec level. Other things like attachments, output descriptors, and cryptographic seeds are just essentially how you format information within an envelope. So for exchange of these data types, and they don't require any actual extensions to the codec itself, which is why some of these are labeled extensions and others aren't. So with that, is there anything else you want to discuss on this slide, Christopher?
No, I mean, at some point we need to talk about, the consequences of getting some of the early tag choices we made, and how that, how do we transition for people who've deployed stuff, but we can talk about that when it's appropriate.
Sure. I mean, yeah, just to quickly summarize that, early on, we looked at the IONA registry of CBOR tags, and we picked a bunch of what we thought weren't really low numbered tags because they just said, you need a spec. It turns out that what we didn't know is that these specs require fairly close scrutiny by the CBOR experts before they're going to assign a tag at that level. So, but we released a couple specs for things like HD keys and output descriptors and things like that we use these tags in the 3 to 400 range for, and so we're essentially squatting on those tags, and if we'd known what was going on with that, we would have done it differently, but there have been a couple developers who've released things that now support those, and so we're considering those fixed for the moment, but we'd like to find ways of migrating away from them so we can be more CBOR working group and IONA friendly. Obviously, there's nothing stopping us from doing that in a legal sense, but to fit into the structure of this environment better, we'd like to do that in the future.
So the consequences, for say Seed Hammer and Thunder Biscuit, is that at some point, I mean, our code will continue to accept the 300 tags. But as we add features, more capabilities or whatever, we're going to recommend people move to the more current tags, higher numbered tags.
Right, either higher numbered tags or the versions that can be represented entirely in Gordian envelopes, sometimes using the known values, which are essentially integer-based tags. No, they're not really tags. They're just single semantic values that represent concepts. So, for example, if I go actually to the document that describes known values, at the end there's an appendix, which is basically, some of you may recognize there's actually URLs for various ontologies here where they match. And so this is a new namespace essentially that we're defining. We are eventually hoping that we'll have some form of structured governance, which this document talks about, where we assign these code points to essentially mean, various kinds of classes, values, properties that might be expressed in an ontological framework. But these aren't tags in news. They don't tag CBOR. They just exist as, for example, often as a predicate in a triple. So, yeah. So, moving on. Okay, so we're going to talk about attachments for envelope, and this is something that we've talked to a number of developers, and they basically want to be able to say, okay, what if we want our own kind of vendor-specific information in a seed? And so we want to be able vendors to be able to incorporate their own data into envelopes of any kind. And our kind of use case here is seeds in Gordian Seed Tool. So we defined attachments for envelopes. And real quickly, let me jump over to that document here. So this is Gordian envelope attachments, 2023-06. And so we talk about our motivations here. We talk about which known values we're using. Attachment vendor conforms to. These are, again, single integers, so they end up encoded as very short numbers inside the actual encoded envelope. Real briefly, this is what a seed looks like in envelope notation. This is a 16-byte, 128-bit seed. It has three assertions on it. That when you see them without quotes here, these are known values, including here. These are actually encoded CBOR UTF-8 strings. So you can see if they don't have a quote around them, they're a known value, but they're being decoded here into human readable form. So the subject of the envelope is the seed itself. There's assertion. This is a kind of what we've evolved as a typing assertion. You can actually have more than one here, but right now this is a seed. It has a name of dark purple aqua love, which is one of our standard test seeds, and this is a note. And these two things are optional. And we define that in the seed document. But now, so if you want to add an attachment, then what we want, you could just basically add anything anywhere, basically, because you could add assertions to this particular predicate if you wanted to. But we want things to be highly interoperable, and so we want our attachments to be discoverable. And so we've defined a specific known value predicate, which is attachment. And that's followed by a wrapped envelope, which can be anything you like. This is basically considered to be like a black box by Seed Tool. And it has to, and then it has assertions after it. It has to have one specific assertion, which is vendor. In other words, we want you to say who you are when you put this on. And optionally, you can say this conforms to a particular spec. And then this becomes kind of a ride along with this envelope. And if you've studied envelopes, then you know that as long as you don't have two duplicate assertions, for example, you can't have another is a seed assertion, but you could have another is a something else, because this assertion has its own unique digest. All the digests in all the assertions have to be unique, which basically means you could put more than one attachment as long as it's different. So a little bit further down here, you see I have actually two attachments that are ostensibly two versions of the same data by two versions of the same spec by the same vendor. And that's totally legal because these are actually, these have two different digests. And so we basically, have written this in very kind of spec form, and then we basically say the applications that process envelopes in which attachments are supported. They may implement support for attachments they understand. They may reject envelopes with attachments they don't understand. They may ignore envelopes with attachments that they do not understand, but note that ignored attachments still contribute to the digest of the envelope. They may store the envelopes attachments for later retrieval, which we are doing now in Seed Tool. They may transfer an envelope's attachments to another envelope when it makes sense to do so, such as when a new envelope is created as a variant of existing envelope. That's like if you have the name or note. The way our implementations work is all our envelopes are immutable. So you basically construct a new envelope that has what you want in it changed, and that's what we're doing with this. So we copy over the attachments into the new version of the envelope with the updated name or note. And may notify the user that the envelope contains attachments, or provide affordances for the user to view or edit the attachments. So again, we're striving for transparency here. What is inside this black box, this wrapped envelope? That's totally up to you, the vendor. Whether you choose to document it publicly, that's up to you, the vendor. Well, we just want to know, where this thing came from, which is why this one's required. So that's basically the structure of attachments. Now,
and some of those things could be, relatively standards. So you could say, the com.bitcoin or whatever, core, com.core Bitcoin or whatever, and, to a BIP, or something of that nature. So, and obviously, as we coordinate things, there may be other, items where different vendors have slightly different interpretations of the same spec. So it can be useful for, say, foundation devices to have, yes, this is a descriptor in such and such, but it's more constrained than that because we only support these two kinds of descriptors. We don't support all descriptors or whatever. So that is some of the logic for that. Ori, you had a question?
Yeah, I was wondering like, so the vendor thing, it looks like it's almost like an object ID kind of thing. So I'm just like wondering if there are existing CBOR, COSI or HOSI like conventions here. Like one thing that I might expect would be like a media type or a constrained media type expression for these.
Well, so the vendor itself is, we define that as vendor assertion is required and must be a string that uniquely identifies the entity that added the attachment data. It is recommended that it be a reverse domain name. So that's basically taking its cue from kind of Java precedent. It may not be an empty string. It may not be any other data type. It may not be any other data type or have additional assertion. There should be an or there. So this has to be a basic string, human readable string here, and it needs to identify the organization that added the attachment. Now, the actual spec it conforms to, this is a URI or URL. And then this could be any CBOR whatsoever in here. So that's totally up to the vendor.
Right. I guess you have two string fields here, and instantly it's sending off alarm bells, like because strings are massive and large, and they're not necessarily always the CBOR way to express things, but because they're kind of unbounded in terms of what they can represent, it does make sense that these are strings. I guess the question is, have you thought about expressing the media type of the attachment? Is that a concern? Would you use the existing mechanisms for expressing media types in CBOR and the COSI and
The type could be expressed as a URL, can't they?
So if you are by media type, are you referring to the contents of this attachment, the actual attachment itself?
Yeah, I'm referring in this case specifically to the constrained application protocol media type definitions.
Right. So are you referring to the CBOR kind of right? Well, are you referring to the what was it called? Yeah, I think this refers to constrained media type, which, yeah, I mean, there's no reason why we couldn't support those. I haven't taken the time to say that that's an option here. I don't see any reason why we couldn't add support for things like that. Right now, and again, this is a conversation we can have, and this is the kind of conversation we want to have around this. So this is our first take at this. This is, like I said, this is or an early draft. We've implemented it in our and we're supporting it in seed tool, but it's example, it's an example. So there's no reason why we couldn't define other things here like media type and define how they are expressed. And like I say, this is going to be each of these, because their known values are going to be like 2 bytes in the actual thing. These could also be some other more kind of compact form. And obviously this is all dressing around 16 bytes of a seed. So, obviously we don't want to create huge bloated attachments if possible, but there might be some reason. I mean, if you want to attach a video in here, you could, but we'd like you to document what, that you did that and how other people can decode it. That's the most important thing. And of course, like I see, wherever you see strings here, if we haven't said it must be a string, then this could be anything. So I'm using a string as an example here, but this could be any CBOR as long as it conforms to DCBOR. I don't know if I'm getting any closer to an answer for you.
So we'll take a look at that particular RFC, and but I believe that it would just be instead of in the next version of the spec, instead of saying it, recommended it be a URL, it might be it's recommended to be a URL or a constrained media type, and as we add to that list.
Yeah, I mean, it could be that media type is the right answer. It could be that media type is a different answer to a different question. Maybe the user has both questions. Maybe they want to know what media type is, and then also they want to read a URL that's going to give you some information around documentation for it. And I'm just sharing things that seem to pop out as I see.
What's inside this envelope? Since what's inside this envelope is completely vendor definable, then you can also attach media types in here as assertions to the envelope you put in here, and basically define it any way that you think is applicable for your data type. This is completely a black box as far as readers of envelopes are concerned.
Let me pop up a level. So the goal of, both the collaborative seed recovery project, which is our immediate, this quarter goal to have a good solid proof of concept and some specs and a reference implementation that people can test against, and also the collaborative key management, is that, our backup, in particular in the cryptocurrency wallet field, it has been very oriented to just backing up the seed. But as we have more and more types of things that we're doing, in the case of, say, multi-sig, you need to know the XPubs of the other parties. In the case of certain protocols, you need to back up the maybe a pre-signed transaction for certain kinds of protocols. Maybe you need to store different kinds of lightning channel details that are in progress, or long-term lightning channels, et cetera, and not being able to exactly, every wallet has sort of different interpretations of this type of stuff, some of which can be just because foundation devices, for instance, can have one seed. There is only one seed you can have in that entire wallet, whereas, say, our software wallet on iOS can have multiple seeds, and that means that we may have slightly different interpretations of certain kinds of metadata that is included there that may look like, oh, it's a descriptor, a name, or whatever. But in fact, it's more constrained than that, because we might say, well, you can put a name in there, but it can't be greater than 500 bytes because everything has to fit on an NFC. And that's why we wanted to be able to have this conforms to capability at a vendor level, where a vendor can basically say, yeah, this is a metadata field for a transaction note, so you can know what your private transaction was sent to. But one wallet may sub it and go, hey, but our notes can't be greater than 80 characters. So that's kind of the intent of being able to do all of this type of stuff, because I don't think we're in a spot where we can formalize some of this metadata. Some of it is really tied into specific hardware, a specific chip, a specific transport format like NFC, et cetera, that we want, if you can interoperate, we want to make it easy to, so it's needed to be discoverable. So that's a lot of what this is about.
And by the way, it just occurring to me thinking, you're right. I don't like URIs in general for two reasons. One, they're big, and two, they're not very deterministic. And so the kind of the envelope-ish way of doing things in this case is to register a known value that represents that, say, like this URI or something like that. And then you have a 3-byte value that just replaces this entire URI here. You have a 3-byte value that replaces this vendor here. Now, I haven't spec'd those as a possibility here, but they should be probably, because wherever you can have these huge URIs, in fact, the whole conforms to and so on. These could be ontological URIs. In fact, but I don't want to do it that way in envelopes. I want things to be smaller. I don't want things to be more deterministic and less open to encoding differences. So yeah. So and like I say, we don't have a formal governance for for registering known values yet. But hey, if you email me and you say you want a known value, I'll give it to you. So we'll just update our current registry, and eventually over time, maybe it'll become organized by or overseen by an organization like IANA. In the meantime, yeah, you may raise a good point. There's no reason to make this a big URI when you could just make it a tiny integer, as long as you can recognize it and look it up somewhere what it means.
Also, there are tricks. I know CBOR LD, which has a number of things I don't like, but one of the interesting tricks that they do is they hash all of these. So it's still not small, but it is smaller. You have to know as the interpreter of things. Oh, this is a hash of a URL that is well known and we use it. So there may be some other tricks we can learn from there. Our key thing though is for this fall's goal of having multiple wallet companies begin to exchange metadata along with their seeds. We wanted something that was relatively simple, straightforward, that people could do now, so that you could bring your seeds off of a Foundation Devices wallet and put it onto another wallet, and vice versa, bring it back. So and have as much of that wallet metadata be preserved as possible.
Yep.
Because otherwise it's not self-sovereign, in my opinion. If you can't move it without using a third party, then it's not self-sovereign.
So one of the things we wanted to show with regard to kind of the flexibility of this is we have both our seed tool, which is a iOS app, and we have our command line tool, envelope, which manipulates Gordian envelopes. And so we created this. This is currently in HackMD. We might publish this somewhere else soon. But this is basically an example of how our tools can be used to interoperate. Because, for example, right now, Gordian envelope doesn't let you add attachments to seeds, but it does store them. If you give it a UR with attachments, it will happily store it. It'll validate it, make sure it conforms to the spec. If it does, include the fact that what's inside that subject wrapped envelope is total black box. It doesn't care, but make sure it validates the assertions. So this is an example of walking through. For example, starting with our current have test seed here, we back it up as a Gordian envelope, and this is the actual envelope itself. Now here we're in the shell, we're assigning that envelope to a shell value. This is the actual raw CBOR, and so we're looking at the diagnostic notation for CBOR, and this is standard RFC diagnostic notation for CBOR. And so, but you can see here's all the pieces of the envelope here laid out, and these numbers here. This is a CBOR tag, which indicates a leaf enclosed CBOR. This raw integer here is a known value. And in my older envelope format, before we got the 200 tag assigned, it was all these numbers were all basically retagged inside envelope. Now as you can see, it's nothing. There's no tag except 200 on the outside here. This is actually a known value itself too, a different known value to a 200, not a CBOR tag, because it doesn't tag anything. There's no parentheses after it. So anyway, but this is not this. If you want to see the CBOR, this is the way to do it. If you want to see what the contents is, you just use the envelope tool with its native format mode, and you get envelope notation, which is much more human readable. It translates those numbers to actual human readable strings, and this lets you kind of see what's inside the envelope. And this explains just the kind of what the various things mean. So now we're going to construct the seed for ourselves. So I take you through the steps of starting with just the subject, which is just the data of the seed. This is the envelope that looks like, and this is what that looks like when you print it out. That's just the bytes 16. And then you basically add the assertions to it. You start by adding the name, then you add the note, then you add the type, and then finally you add the date. And again, the date itself as well. This is not stored as a string. This is stored as a numeric value. And we have a note which explains how we do that in a very CBOR and DCBOR friendly way. And so now we can basically show that the envelope we just constructed is in fact identical. And the easiest way to check the two URLs identical is look at the last 8 characters, because that's the CRC302 checksum. If they match, everything else matches. So because the first few bytes might be the same, but the last bytes, if the last bytes are different, then the URLs are definitely different. So then we're going to go ahead and add an attachment. So now we reconstructed the same seed that we got from envelope using the command line tool. So this is what it looks like with the attachment added. You've already seen this. So now we actually have we're using the tool piped into each other to basically create just the attachment, including the wrapped envelope as our black box data and the 2 assertions to it. And then we basically add the attachment to the envelope itself. And here we have the complete attachment. And then we can basically import that back into seed tool And then when you look at the envelope in C tool now lets you actually look at the envelope notation of it. There it is. And that has persisted. This is all you can do with it. You can't manipulate this at all. But it rides now along with C tool. C tool persists it and will export it back out again if you export it as Gordian envelope. So this document, I think probably Shannon could post the share link, which I think is in the slides here. Let's see. Yeah, there's attachments. Okay, I covered that. Yeah, so this detailed example link, Shannon, if you want to post that to the chat, that would be great because that's what I just showed. And so I think we just covered those slides. So yeah, we want your feedback.
Let me stop a second. So, yep. So I think the key point here is that, you know, we have an app that is available for iOS that you can test against, that does some very basic things, has some very basic metadata, and it is and a command line app that you can do various types of testing with. So if you just simply want to accept a seed from another device, the device can, you can request it, hey, give me, a seed, and it will do so. And you can just take the 16-byte value and ignore the metadata. But if you understand some of that metadata and can use it, you, for instance, have a label for a seed or any of these other types of things, they're available and you can fill it up. So that's when we come to this slide, which is we have a start here with some very basic things, but we really want to add to the list of examples of the kinds of things that might be exported and what are also some of the privacy concerns there.
Right. So yeah. So this is definitely the start of a conversation. Let's see. So the next thing I want to talk about is output descriptors for seeds, which is, Christopher talked about, is basically the start of a conversation around policies and attaching policies. So in our research repository here, we have Bitcoin output descriptors for Gordian envelopes. And this is where we basically, again, we describe the known values that we've registered for use with this. And then we give an example of what a Bitcoin output descriptor looks like as an envelope. And in this case, we're using the same text-based format that is already common in the Bitcoin community for this. And then we add one mandatory type descriptor, type assertion that is, and 2 optional metadata. And this again shows how you can add metadata to anything. And if you're following a spec, it basically says what you can include as metadata and what it must be if it's going to be there at all. Other than that, envelopes are very unconstrained as to what you can put into envelopes. So it's these kinds of specs that are intended to constrain what is a well-formed envelope for a particular purpose. And then if you're going to use this particular envelope as the object of an assertion, then we have notice that there's a difference in case here. This is a capital letter, which indicates it's a class, and this is a lowercase letter indicating it's a property. And so this known value predicate is used as the predicate, and then the object is the envelope we just described. And so this lets you attach a output descriptor to anything. In this case, the subject is just a string. So now what I'm going to show you is a live demo of, so let me actually stop. Let's see. Where are my Zoom controls here? One sec.
E, you have a question?
Yeah, it can wait after the presentation. I just wanted to know whether this envelope formats, are they obsoleting the other specific formats for example, in this case, output descriptors?
Yes. So for the output descriptor format that we defined in CBOR was, I would say, kind of a heroic effort to replace the text-based format. And it is one of those formats that uses a number of those tags, those lower numbered tags in like the 300, 400 range that we are unlikely to get from IANA ever. So, and as envelope came in, it became clear to us that we needed a different approach. And while we are still able to export those output descriptor types from Gordian C tool, CD tool never reads them, but it will write them. So for compatibility, we would like to propose and have a conversation around, agreeing with the community that we should be using these formats, which, at their low level, they're just CBOR. And they're in a rather strict format. So even if you don't support all of Gordian envelope, it's still pretty easy to support these particular formats. So you don't have to have a full envelope stack to just support these particular formats for reading and things like that, because they're pretty well defined and very fairly tightly constrained. Does that answer your question?
Yeah, for this particular type, it seems to me that one of the reasons I like the Bitcoin, the old output descriptor format, is that it's much more compact. It encodes more compactly, which is interesting for us for where we engrave it on steel. And it seems to me this envelope is using just the text format, which will take up much more space. Is that?
It is, yeah, and that is definitely a trade-off. And we again, this is a great time for that kind of conversation. Yeah, this is the text encoded format, the key in particular, is longer than it needs to be because it's using base 36.
58 or something.
Yeah, right. Base 58, right? Yeah, this is a base 58 encoded format, so which obviously isn't nearly as efficient. And that is a compromise we're currently making. But obviously we're not using any other tags. All these are known values which we control. Yeah. And this is something that people widely know how to read and write in various stacks. So that's the compromise we're currently making. And yeah, I'm happy to have a conversation on the trade-offs.
And if it's not the right compromise and two or more wallet companies want to do something better.
Yeah.
I mean, I've talked with Wolf, can we decompose this and just, into a CBOR structure with the raw binary data? And the comments that have, come back is, well, for a subset of them, because, there are some weird variants of descriptors that are out there. Or future features that have mini script in them and other stuff that just makes it really hard to not to make a binary compact form of it. But it may be worthwhile, again, if there are two or more wallet companies that want to interoperate, and I consider you a wallet company from this perspective. That we have, it could be that we have to have a compact descriptor spec that where we're really trying to narrow it down. Again, the use case here is if you've got a multi-sig, you need to properly back it up. At minimum, you need to have the seed and you need to have the output descriptor. Almost everything else is optional. So if we can make that as tight and compact as possible, and there is interest by parties, and it wouldn't necessarily just be, somebody putting it on steel. NFC, we've run into problems with NFCs. The most common NFC card, I think, is 490 bytes, and you lose some of that when you do some of, you lose some of it. So it's not even fully that. And there are people who want to do more with, NFCs and Bitcoin. So they also might be interested in a much more constrained output descriptor thing. But I suspect, we all have to have some tests. If we implement that, we will have to include some things like, hey, if there's mini script in it, use the non-compact form. We only support, these four kinds, witness public key hash and a couple of others. So we'll see.
Yep. Yeah. So so definitely, let's have this conversation. So I want to show you, let's see. So, now that you know kind of what an envelope looks like with an output descriptor in it, I want to switch over my sharing to my actual iPhone. So what you're seeing now is a window on my screen, but it's actually showing you the video from my iPhone on my desktop here. And so I'm going to start with seed tool. These are all test seeds. I'm going to go to the same seed that we've been using along here. And as you can see, this has already got a note, creation date, its name, and so on. These are all kind of metadata around that seed. If you scroll down to the bottom, and I'm going to tap the gear in the lower right-hand corner here, and that's going to pull up the settings here. If you turn on show developer functions, this will show a number of other things here, like, show example request for the seed. You see that green button there. With anything you see with the bug on it is basically a developer feature. If I scroll all the way down, now you see the actual envelope notation output of this, and you see it's already got an attachment. This has been imported as a UR into here, but if I modify the note or the creation date or the name or whatever, the attachment will remain exactly as it is. And so this is now persisted by Seed Tool. And of course, if you have iCloud turned on, it'll sync it to iCloud and all that. So also notice the section says output descriptor. It says associate a primary output descriptor derived from the seed. You may paste either textual descriptor or a UR envelope containing a descriptor. So I have, let's actually do this kind of the long way around first. So we're going to go into our seed here. We're going to say authenticate. And normally it would ask you for your Touch ID or Face ID right now, if you're using the actual version you get from TestFlight. And I'm going to say derive key, other key derivations, and I'm going to keep it on master key because I want to actually derive an output descriptor. So I'm going to scroll down, and there's the private HD key, and then you see I could either go on to get the public key or an output descriptor. So I'm going to say I want an output descriptor. I'll leave it as account 0, and I'll leave it as native SegWit single key. And so now at the very bottom, you see there's the output descriptor. By the way, a lot of the fields in this, if you just tap and hold on that text, you notice how it's pulsing, and then it brings up the share sheet. So you can copy that text directly to the clipboard. A lot of the, like all the life hashes, a lot of things in Seed Tool let you just do a quick share like that, or you can tap the share button here, and there's your this is actually a UR crypto output. This is in fact still the CBOR format, but we also now let you export it as a UR envelope. And then again, the advantage there is it can include an embedded name and note, or just as straight as text. So I'm going to share this as text currently. Copied clipboard. Done. I'm going to back out of this. Now I'm going to have this on the clipboard. Now I'm going to paste this into the notes so you can see what I have on the clipboard. So that's exactly what I had just copied. That's also part of the note, which is where I think Christopher was storing these things. So let's get rid of that. And now let's just hit paste on this button on an output descriptor, and boom, there it is. Now this has actually been validated. In other words, this has been validated as not just being a syntactically correct output descriptor, but also having been derived from this seed. So if you try to paste in an output descriptor that wasn't derived from the seed, it will not let you. At this point, you can tap and hold on this and pulse that to copy, or you can hit the share. And then again, you can share it as Gordian envelope or as text again. Let's take another example. I have an example on my computer of a longer Gordian envelope. Let me copy that. I'm going to use the continuity paste here, paste it from my desktop. Okay, that's a longer envelope now. This is a UR envelope, so you can see what's on that here. And then I'm going to say remove the output descriptor. And now I'm going to paste this. Now it accepted it. Notice that now it's also showing the name and the note attached to this output descriptor. And if I scroll down and look at the envelope, you can see there's the note, which included the pasted output descriptor there. Let me go ahead and get rid of that. Verify things here. There you go. So there you see that I still got the attachment. And it's got the output descriptor with the actual textual output descriptor and the assertions that identify it, including its own metadata. So, so this is basically, and then just as one more example here, I've got another output descriptor from a different seed here, and that's what that looks like. And so let's try replacing this with that. Remove. Paste. And so it gives you a very clear message that this descriptor doesn't belong to the seed, so it's not going to accept that. So so yeah, so that's basically associating a primary output descriptor with that, and that's in line with the specs on our in the BCR. And of course you could compose this output descriptor, including the note and name from the envelope tool if you want. And so you can go back and forth. You can go from here back to the envelope tool, from the envelope tool back to here. And that's kind of showing how we're building this ecosystem of envelope-based tools and techniques.
And the
Any questions
focus
on
of this particular release, and also the CLI examples that we're giving, is really not yet intended for the broad Bitcoin community. It's more so that you guys have something you can test against. You can have a private metadata and, paste in the envelope with it, and, it will show, it'll do the right thing. We felt that was important for you to be able to experiment with, because we don't know what the right answers are for some of this. So we've had in the past, for instance, a date field that was the seed creation date, because that was significant for a number of wallets that were cared about when the seed was created, because it can take a long time for it to discover a transaction. It could basically ignore everything before a certain date in a light wallet. If there are a bunch of people that need that, it's very important to their model to have a birthday for a seed. We need to know. Just we want to prioritize these by ones, features, data that is currently being used, and get those in and try to standardize as many as we can. And some won't be standard, it'll just be proprietary to your wallet. So as an example, Foundation Devices probably has some metadata that is useless to anything except for another Foundation Devices device that has the corporate private keys of the manufacturer on both devices. So they could basically put in a private envelope in there that basically allows for export of some of that data from one Foundation Devices a wallet to another one that everybody else will just ignore. And that's perfectly okay too. But we need to understand these things. And then there's a lot of very interesting, complex futures. There are interesting emerging protocols that require adapter signatures. Adapters are typically random numbers or apparently random numbers. So we may need to have some standards by which either a seed for an adapter signature is kept separate from keys, or there's some policy, in the same way there's a policy with descriptor for how those adapter values are created. Or it could be just, it's a list. We don't know. We need to understand, what are your immediate needs for storing this type of stuff. Lightning also has some particular challenges. For wallet, exchanging a wallet, you basically ideally need to back up the current channels that are not closed, and then be able to move them to the other wallet, and then be able to have that wallet take over those channels. So
there's one other thing I wanted to quickly mention. Let me share my screen again here quickly. So now that we have the let me actually put this back here. Let me get my big output descriptor here. Sorry for the duplication here. Oops. Okay, so there we go. So now we have the larger envelope size here. So I go back to my, so you say authenticate, and I say backup SSKR. Now, envelope, the C tool now lets you decide whether you're going to back up as SSKR as a Gordian envelope or as legacy UR crypto SSKR. If you choose this, there's no metadata. It's just the seed that's backed up, because basically SSKR only supports up to 32 bytes. Whereas Gordian envelope, if you use SSKR as this, say 2 of 3, you say next, and you say, you can print all shares individually. Now, if I say show the envelope for this, here, there's the envelope. As you can see, it's much larger, but this is actually an SSKR share, but it includes all the metadata encrypted, and the actual what's being sharded now is the key that will decode this envelope, and you need 2 or 3 shares to do that. So I show the QR code. Obviously, we're supporting our animated QR codes, so we're unconstrained by size when it comes to air-gapped communications as well. We can also write these to an NFC tag, and so on. So, we're basically allowing a lot of different ways of interchanging these things, but envelope basically removes all the kinds of size constraints, and the fact that we're using fountain codes for our animated QR codes, so on, removes those size constraints. And you can have unlimited metadata and things like that. So again, this is the value of the whole ecosystem. So I just want to mention how that all integrates. So I guess we can go back to the slides. Here.
There was a question from E about how do we envision? I mean, I think the key thing is we have, over a dozen companies that have done PSVTs. We have a couple of companies now that have been actively supporting our work. And it just starts with 2, we just need 2 companies basically go, hey, we believe in self-sovereign computing. Self-sovereign computing includes portability. We need, people can't, it shouldn't be locked into just the Trezor or just the Ledger or whatever once they start using those types of those tools. And then we just need more people to demand, hey, you need portability of the data. I don't think it'll happen in the Bitcoin ecosystem in the short term. But if you're in the EU, there also is a requirement for portability in the EU under EU law. So it'll be interesting to see, how that evolves, because we do have companies and parties that are interested in other kinds of wallets. Among which is, Ori has, a number of different things that are going on there that are not Bitcoin wallets. So we need to understand their requirements and things like 25519 support and such as well. But we think that that'll solve, the problem of at least bootstrap, getting people involved. Does that help, E?
Yes, it does.
I would more generally say that we've seen the best pickup when we met a need. That was what happened with PSVTs. People couldn't get them across air gaps until they adapted animated QRs. And the need here that this is most directly addressing is the need to get metadata out, such as the descriptors. And so even if people aren't saying, hey, I want privacy for my customers, they can say, hey, I need this metadata saved, start using envelope, and, maybe look at the other functionality later that we want them to look at more.
I mean, there are also a lot of interesting things. I mean, most people, including, say, Ledger, which I, came out with their very proprietary scheme for secret sharing. Is there a lot of interesting scenarios out there? So, for instance, I could have a 4 of 9 where maybe 3 of 9 is set up with a specific sub-envelope that allows me to recover my seed. But if I want to recover all of my metadata and transaction records and who I sent, what transaction to privately, that is alighted in some form or is in a different envelope share, such that you have to have, a 5 envelopes restored to you to get all that extra data back. There are interesting constructions because, again, envelopes can be inside envelopes. So right now we've just described, a particular envelope with the focus on say SSKR of a seed and the seed's metadata, but that could be inside a larger envelope that is, oh, I'm actually giving you one of my 4 of 9s. I'm giving you a different 3 of 7, and I'm giving you a 2 of 3, which just simply has hints as to where you can, who the different people are that you can ask for to get get the data you need. So, might not even have cryptographic. The 2 of 3 might not have any cryptographic data at all in it. Or could be a 2 of 9 or whatever. I don't know. But you get my drift. There's a lot of opportunities to construct scenarios that address the resilience and reliability without without compromise of that are possible with a single key solution or even a 2 of 3. So that's why I'm kind of looking forward to some of the seed hammer stuff, because seed hammer doesn't necessarily have to have all the envelope. They only need to have the portion of the envelope that is necessary for, say, an emergency. The storage within, locked up in a safe at grandma's house or in a bank in Switzerland or whatever. You can elide all the data that you don't really care about. It's still valid. And can be used as an emergency share, whereas, one of the shares, that is, could have a hell of a lot of metadata, could all be stored in iCloud, but you can't pull any of the stuff out you need without, collecting shares from other parties. We think this addresses a lot of potential scenarios and gives a lot of flexibility for people. So but we need you. We need your list. We need things like, somebody basically going, oh yeah, we're putting names in there, but we're also using names so they have to be unique. And I'm going, that kind of works, except for some multi-sig things where you might have 2 of the seeds in a multi-sig, not just one. But we need to know these things. Go ahead.
Yeah. So my other question is more of a process question. Is these names, they're already names defined for extended keys, crypto-HD key, which I guess again is an obsolete format or will be. So my question is more short term. Will there ever be a name, an overarching name, not for each cosigner, for the crypto output standard? Because as far as I can tell, it'll be obsoleted by the envelope. So I'm just wondering, will this?
You're talking about the human readable outside,
just as there is for a crypto HD key.
So again, the fundamental problem we discovered with our CBOR, some of our CBOR structures that we already defined, and this is definitely to our chagrin, is that we're using tags that IANA is unlikely to ever grant us as allocations or as assignments. So and so
what he's actually talking about. What he's talking about is, right now you can, because the outermost tag in the UR text format is expanded to a human readable form,
right,
has this UX advantage of, oh, here is a piece of steel and it says crypto output, UR : crypto output on it. And that gives him a, the ability to say, oh, well, this is, hey, go look up crypto output if you want to know what this is. Whereas now he's going,
envelope is much more opaque in terms of what type it contains, if it contains a type at all, because that's a known type at all, because obviously envelope is designed to be a very flexible container for data, whereas it's not, and when wrapped in a UR, it only identifies itself as that kind of flexible container, and I understand that there's definitely a trade-off in terms of human readability and ergonomics there. And I've thought about what we might be able to do about that. The main problem that I've always tried to avoid is having more than one source of truth. and so the way that URs in general work is, a CBOR structure, a tagged CBOR structure, when you put it in a UR, you exchange the outer tag for that human readable string on the UR, and then you exchange it back if you ever convert it back to a tagged CBOR structure. So envelope is only ever tagged on the outside of 200. Now, is there possibly a way of adding some kind of annotation to that? Yeah, but that would be advisory then. It wouldn't be necessarily something that says, here's what's in this envelope.
Maybe we're talking across from each other, but not speaking of the same thing. The issue number 133 that I linked to is simply about adding a name field to the CBOR structure for crypto output. Nothing to do with the UR encoding.
Yeah. So I mean, right. So it's, I would say it's possible. I mean, certainly we could add it. Certainly, there's the question is this direction we want to continue heading in as a community at this point? Yeah. And I would say since, my first gut reaction is ideally no, because not only are envelopes, more flexible and also very still compact, and yes, in the output case, we're building this on a text-based format, which is less compact, and that's a conversation we can have. How do we make that more compact? And that of course, right now it's because it's envelope, it was trivially easy to add that field, to just spec it in and then support it, because envelope is that flexible. And so I guess with regard to your issue 133 there, this is a conversation I'd like to have about the trade-offs with you in terms of, do we continue to pursue this, even especially because it uses tags that, we're going to have to either renumber or just agree that we're kind of going against the grain with IANA, or is this something that we can make a smooth transition to envelope and, get the benefits without the penalties? So I guess maybe my question for you, and maybe that's a question we can have offline here, is, your use case, obviously, you're valuing compactness. So maybe I need to understand more about the use case so I can figure out how to structure a solution that makes everybody happy. I think
there's some other things here. I mean, the bottom line is, although we are not a international standards organization, we do create commons specs. So a lot of it, I think, is, what does Sparrow want to do? What does other people want to do with this, older spec? I don't have a problem if everybody's kind of aware, hey, we're going to eventually need a transition to 2.0, but we're fine with issuing a 1.1 update, to allow for some immediate interoperability by people who want it now. And
I don't see, for me personally, I don't see any value in doing 133, even though we would need it or we would like it, because from our point of view, the major problems that we have, other than the new format may not make the output descriptors as compact as we would like. But apart from that, it's the change of standard in an environment as we see it that is very little standardized. That doesn't have much standardization. Blue Wallet has their format, JSON something with the descriptor embedded, and I think Nunchuck and probably others have Nunchuck and others have a JSON format. Blue Wallet has a text format that is line based, that lists every key. It's very it's not obscure, but it's very inflexible and so on. So the reason I bring this up in the title is we were starting to think of nudging all wallets doing blockchain commons work, in the sense that we're all in this together. So it's not doing for you, it's for advancing the standardization on output descriptors. And so this is a very interesting meaning, for we were just about to say, okay, we'd like to nudge wallets to standardize on crypto-output, the BCR 2020-010. But we just need the title, because that's what all the other proprietary formats do. They have a title for the descriptor or wallet or whatever, and they have the title for each code signer, and then the XPubs. So
what I would say we would need to do as a community, if we wanted to have a more compact version, is we would need to do a new version of crypto output 2.0, that doesn't use any of these low numbered tags, only uses that basically transitions to higher numbered tags, which would mean they're probably going to be another byte per tag or something like that, because that's the penalty. That's the trade-off, is by using higher number tags, you're going to pay a slight storage penalty. And then just, and then add that field to it. And then that would basically be, and maybe add a field for notes as well. And then you would basically have the CBOR equivalent of what we currently have for in envelope without using text. It would still be, I think, be more compact. And so, because we already have that now, as Christopher mentioned, the problem there is tracking the the fluid and ongoing nature of output
Yes.
descriptors themselves, and their format, and the fact that people have a lot of different kind of hairline variations between them. And are we trying to bring everybody together under one roof, under this this binary encoded roof, or are we trying to track this moving target of the text format? So again, these questions aren't answered, and we're very open to kind of having this conversation.
Well, I think even though CThammer has a requirement for compactness and terseness, I still think we were wondering whether we should switch to a textual format, just because it has such a standardizing force right now behind with Bitcoin Core supporting it. And so the common theme among wallets that are descriptor aware is the textual format, and some of the export formats do also use the text format. So what I would I've only known about this particular envelope type from this meeting. What I would think is, could we keep the text format or tracking the text format and only compress or do slightly compression on the large items in a descriptor, which to my knowledge is the XPubs or the XPubs.
Let me think. Let's think about that. I want to. I know that Ori wanted to discuss something as well, and Thunder Biscuit. But I think we understand the problem. I think we clearly I mean, that's part of why we did it in an envelope form rather than just revving crypto output, was because of these things that you were just talking about. And but the reality is, nothing we do moves out of research until there's 2 or more companies that have actually implemented it in some fashion. So we just need your help to get them to come to the next meeting and have that as a specific topic, or talk about it on Signal and in the GitHub community and in issues to kind of drive this forward. So I'd love to have the Nunchuck guys here. I'd love to have somebody inventory. Shannon got a copy of the metadata that Foundation Devices has, or at least for maybe last year's device. So we know kind of what theirs is. We just need to start inventorying these things and prioritizing. And
and I would also say that just in passing, that because we have a textual format in the mix here, our envelope stack supports compression using the display algorithm, which could conceivably give you 40 to 60% savings depending on the nature of the data you're compressing. And it's just kind of baked into envelope when it comes to technically it's an extension to the core, but it's in all our reference implementations.
There could be other. I mean, like I'm thinking, like the specific problem with descriptors is the XPub portions are not easily compressed by, say, because they're effectively ran.
But because they're base 58 and not full binary, they actually do have a lot of unused entropy there that can be compressed out.
Well, I just don't know. We have to test it, but that's
I know. That's what I'm saying. We can test it, but this idea just occurred to me, so I want to throw it out there that hey, we can compress the envelope or just the subject of the envelope, which is the text-based format, and it's the exact same envelope, has the exact same hash tree. It's just tinier, and as long as you can decompress it on the other end, then you have a fully isomorphic version of the envelope, but smaller.
And and we also can have multiple compression types. So if it's really that important, and there are a number of people who want to do it, we can do the kind of magic trick that, say, QR codes have, where we encode it, we compress it one way up to here, and then there's a special tag that says from here to here is binary, and then then a new thing basically continues the other compression format. If we need to, we can do stuff like that, but we need to understand the problem, and again, have 2 or more companies say, yeah, this is a hard problem. We want to solve it. We want to interoperate, and we'll help write that compression codec if we need to. So anyhow, let's move that to issues and discussions. Ori, actually, do we have a slide for Ori?
Let's see here. We have a second here. So we have the next slide was the new developer web pages. Let's see what else we have here. We have
Yeah, okay, so let's quickly, Shannon, can you quickly let people know about the new pages?
Yeah, basically, very quickly, we have a set of new developer web pages at developer.blockchaincommons.com. We cover, I think, 11 different specifications or projects that we're working on, roughly divided into data format, seed recovery, and UX design, which are kind of some of the hard problems we're studying. We also talk about architecture overall, and we have a good list of all of our libraries that we know of. At least every once in a while, we find one from someone that we didn't know about previously. On these pages, our goal is to obviously support developers. We found that with use cases, we go up to test vectors, and we often have direct documents on how things work. I would say and each page has a nice overview too. If you're wondering why in the world would I want to use this, we talk about why we think it's important and how it generally works for every one of these 11 different specifications. Because we pulled these off of the repo, sometimes we found we did different things for different ones. Like we have test vectors for some, use cases for some, and not for others. So if you're looking through these and you say, hey, I really wanted, this element that I see on other pages that isn't on this one, just let us know. You can email us, or you can just put an issue in the developer blockchaincommons.com repo. But our goal is totally to give you what you need to use our specifications, our libraries. And if you don't have in these new pages what you need, let us know and we will get it in there.
Okay.
Okay.
Okay, Ori, why don't you say a little bit about yourself, and then let's talk about your disclosure.
Sure. So I'm Ori Steele. I'm CTO and co-founder at Transmute. My background's in cybersecurity. I'm author and editor of various digital identity and digital signature enveloping standards at IETF and W3C. So I mostly work in the HOSI and COSI working groups at IETF, and mostly at the decentralized identifier and verifiable credentials working groups at W3C. And my company Transmute applies these standards to securing supply chain scenarios. So in the credentialing and identity space, a lot of the time you'll hear folks very interested in personal credential use cases, digital driver's license, COVID vaccination, etc. And the design experience for personal credentials is complicated by the fact that the user is really often very much in the loop, and you want to make sure you're getting consent. And how are you going to present user experience around digital signatures to users and that kind of thing. But in the supply chain world, in the business credential space, a lot of that, those same kind of user experience concerns are not present. A lot of organizations and governments will do legal agreements with each other, and then they will share data in a really high volume data pipe under a pre-existing agreement. They're not going to prompt you for permission every time they get a new data message, regarding an import process, for example. So it's a different different kind of experience in supply chain security than it is for personal credentials use cases, but a lot of the building blocks are the same. And one of those building blocks is this concept of selective disclosure, which you are all super familiar with because Gordian has it built into the data format. For folks who aren't using Gordian, they've had to build selective disclosure on top of the existing tooling. And that has come with some advantages and disadvantages. And one of the digital credential formats that's gaining popularity in the personal credentials use case is this SDJWT format. I think I had shared in the discussions thread was a link to the test vectors and the spec for it. But just sort of summarizing how it works briefly, it encodes nested JSON hierarchy into a set of messages that can be disclosed, which are committed to in a JSON Web Token. So one signature on the JSON Web Token encodes the commitments, And then the commitments are, the values of the commitments are revealed by the holding party. And that turns out to work really well if you've been issuing JSON Web Tokens your whole life, because it's just another JSON Web Token. You just have to do some fancy pre-processing, and you have to add on some extra disclosures on the other side. There's obviously some awkwardness around that because JSON Web Tokens are text encoded, and you can't just call the JSON Web Token with selective disclosure actually a JSON Web Token, because it has different serialization rules and other details like that. But SDJWT seems to be gaining a lot of popularity, personal credentials use cases, and one of the things that we're excited to be working on and thinking about is like, what's the SDCWT experience? And you have the same set of challenges. A CWT has a structure to it. So it's CBOR, but it's CBOR with registered claim names from the CWT registry. So it starts as a CBOR map, but then, one means issuer and all of the other registered claim names sort of apply. And you can get some kind of registry enabled semantic compression from that, but there's scaling issues that come with it. Like, how many entries are you really going to add to the CWT claims registry? And I'm not here to talk to you about like SDJWT or SDCWT really specifically, because I think Gordian is kind of taking a different approach than both of them, and there might not be anything real usable for Gordian from either of those. But there is this thing that seems to be growing in popularity, which is using YAML to write CBOR. So YAML is a data format. It's sort of like JSON, but it has some additional capabilities. Like you can have maps that have integer keys, not just maps that have string keys. And YAML also has a semantic tagging structure, which is interesting and can be extended to kind of add different serialization or deserialization capabilities at the like YAML language boundary. And that's kind of one of the things I wanted to share with you all today. And I'm just going to paste the link to this test. So there's a prototype pull request, which is in a branch in a repo that I've been experimenting in, so it's real messy, and I apologize if you look anywhere else in here, you will be disappointed to see I have awful Git commit hygiene. But the point about this is this SD exclamation mark in the YAML tag. So I think it's on line 25 on the file that you're looking at here. You can see there's this YAML semantic tag exclamation mark SD. And it actually it's Unicode, so it could have been exclamation mark some emoji, or whatever you want it to be. I think I'm super big fan of seeing more use of emoji, particularly the emojis that have expression of color or whatever in these places. Of course, there's usability issues around color blindness, etc. But the point here is that this SD is saying the property of this is a map of claims, and this string key with this A string value is selectively disclosable. So they've annotated the YAML in a way that allows for, when you parse this thing, to automatically, when you encounter this piece, you're going to handle serialization of it differently. So I might import this YAML file and give it a digester and a salter. And if I import it with the digester and the salter, and then I serialize it back out again, it'll get encoded in a selectively disclosable way. And it feels like there might be something useful for Gordian here. Like, YAML is very writable. It's very readable. The semantic tagging structure could be a great way to kind of write YAML that creates Gordian kind of CBOR to some degree. The tags are really extensible. So, I'm only using one in this example, but you can add however many custom tags you need for your YAML use case. You might be able to say, hey, this is binary that's text encoded here, but you know, when you make CBOR out of this, like I kind of want you to remove that text encoding, you know, because it's going to make the whole object larger than it needs to be.
It
And
just occurs to
another-
me that this would be a good technique for translating between known values, text formats, their canonical names, and their integer values in back.
Yeah, possibly. Like that's that's why I wanted to bring it here to talk with you all about it. Because another area that we see like a lot of pain, you know, coming from is like text encoded URIs that are encoding binaries. So data URIs inside of JSON, for example, it's like if that JSON gets base64 URL encoded again, and you already had a full image data URI encoded in it before you inflated it again, you get this like massively large JSON object containing a data URI for an image. And if you could instead write that as YAML that had an annotated data URI, when you compile that down, it's translate that YAML file with annotation into CBOR, you can wipe out all of that sort of expensive text inflation. And when you come back out, you can reapply it. And so you don't end up seeing the pain or feeling the pain as much with annotation. There are issues with YAML, like YAML has some limitations, in terms of what it can express, like it does well with dates and integers and, scalars, which are, Boolean strings, numbers, sequences, which are like arrays with order, or lists with order, and, maps, which are maps. You guys know what they are. Order doesn't matter, but, there's potentially something here. And the thing that I think is the common opportunity for Gordian, for SDCWT, and potentially for the wider CBOR COSI working groups is if I want to write something and read something, but I want it to go to CBOR when I'm done. Maybe this is, it's like CBOR diagnostic, but it's actually more of a data format that you might use, you might have on your file system. So that's like, I don't like CBOR diagnostic particularly that much. I'd like to see YAML with comments over ever using CBOR diagnostic. And I'd like to be able to go back and forth between the human readable representation of deterministic CBOR and the CBOR version of it. And I'd much rather go in and out of a language that has other usage and is getting more widely adopted and deployed. And YAML has become the kind of language of choice for infrastructure as code for a lot of templating because it's more writable and readable than JSON. It's doing better than JSON in some of those areas. So I feel like YAML and CBOR are a good pair together. And yeah, I wanted to share what's going on here. And this SDCWT prototype sort of works. And it's basically a copy of SDJWT, but for CBOR instead of for JSON. But maybe this SD thing is useful to you guys. Like, I don't know. But I thought I'd bring it to you all and share, what we're doing with it. And yeah, happy to answer any questions you might have about it.
Yeah, so definitely should be, thinking some more about that. I mean, we have already kind of extended the CBOR diagnostic notation with sort of a Gordian diagnostic notation.
Yeah, we did the same thing, and it was sort of painful and awkward.
So the question is, is there a YAML-ish version of that? So of the not so much of the a YAML version of the CBOR diagnostic, but more a YAML version of the Gordian diagnostic.
Yeah.
Right. So I see there's definitely kind of a separation of layers here, because of course we use diagnostic notation, in our own development work, and our stack supports it as a form of output for any DCBOR, including envelopes. but you know, it's basically, it is parsable. You know, you can put it into cbor.me and it parses. So although it's not a goal of ours to have our stack parse you know, diagnostic notation. On the other hand, we have this higher level notation, what we're calling envelope notation, which is strictly an output thing. It's not designed to be round trip at all. That's a non-goal for us. But it does give you a much better view of what an envelope contains from, you know, from a higher level semantic point of view. And it seems to me that what you're doing with YAML here is a little bit in between. It's CBOR, but you've got these macros or kinds of things that basically give kind of metadata of how to expand it upon serialization and things like that, or maybe how to interpret it, you know, upon reading. And you know, and that there's definitely sounds like there's some useful things in that space, and there might be some important cases for important arguments for making sure what we're doing is interoperable with that on some level. Obviously, everything we're writing conforms to our DCBOR spec. So anything that you can read DCBOR, you know, in, which is basically a subset of CBOR, so it is CBOR, and convert to your YAML format, then you can basically, you know, in that kind of part of the round trip, you can basically parse anything we output as an envelope and look at it in your format. So that's already part of the ecosystem, as far as I can tell.
I mean, yeah, so you could export, you know, CBOR you know, to YAML, but you lose some of the hints and names and other types of stuff.
But once you've got that far around the circle, then you could also define some of your macros and so on, specifically designed for envelopes that basically like for assertions and stuff like that.
Yeah, I mean, I don't think there's any reason you should lose when you leave CBOR to come to a text encoding. You should be able to keep all of the semantic tagging and precision, and you should be able to kind of hide away any part of the CBOR representation that isn't necessary for your goal. If your goal is to round trip, you can't get rid of it. But if your goal is not to round trip, you could get rid of some pieces of it. You could make, you know, the visual experience you know, maybe more concise or, you know, lossy, you know, but a great reading experience with YAML and semantic tags. So I think, you know,
well, we already, from envelopes perspective, we already kind of got that covered with envelope notation, which is definitely does not sign your round trip. And also we output mermaid as well. So to actually show the whole, you know, tree structure of an envelope. We also have another format called tree structure, which is actually a textual output. So we have a bunch of these output formats. And you know, you can export to CBOR diagnostic notation and then use a parser to put that back into CBOR and parse that as an envelope. But what I see the advantage of possibly doing a YAML tooling for would be so that you could essentially write an envelope in YAML or read an envelope in, and then see a structured YAML, you know, with all the semantics still there preserved.
If you're good enough, you could write CBOR diagnostic and then just compile it down to DCBOR, right?
Yeah. Oh yeah, absolutely. You can totally do that.
But
you don't want to for envelopes, for sure.
The problem that I have with that is it's like, why are we going to go on a crusade to convince everyone to learn CBOR diagnostic?
Yeah, so let's pause here just to, I think this is an interesting experiment. I mean, what I really would like to see, because I don't think Wolf or I are great on YAML. I run into it every once in a while, and I feel like I always have to go find a linter to go help me.
Yeah, you do. But there at least are off-the-shelf tooling that's widely supported for YAML versus.
Well, I use JSON lint all the time too. So
yeah,
I would love it if you could take one of our not our the CBOR diagnostic notation examples, but one of our simple Gordian notation of a simple verifiable claim. Shannon has done a whole bunch of these around some simple verifiable credential-ish. They're not truly verifiable credential, but you know, some things that are kind of in that family for our use cases, and just take one of them that looks rich enough that you could help us by, you know, turning it by hand into a YAML so we can see it. And I think it
so
would not.
One moment, Christopher, I have a concern, which is that if you're talking about envelope notation, it's not round trip. It is lossy. You know, for example, a CBOR byte string, it just prints as bytes, parentheses, the number of bytes. So it's not designed.
I
Yeah.
agree that there's a problem there and I'm just saying though that that it would be better to start with that and then maybe go back to the CBOR envelope. I mean, the CBOR notation to, for the essentials of some of the round tripping stuff. But what I really like about the envelope notation, again, it's just an output diagnostics format, is that it understands envelopes. And makes it really easy for you to see what's really going on with envelopes.
Yeah.
And so I want to have that, which trying to do a YAML off of one of our of a CBOR notation would lose that.
I
So
just think
anything,
what I've seen though, it implies that maybe, obviously I wouldn't start with envelope notation. I'd start with either the CBOR diagnostic notation output from an envelope or the raw CBOR and parse it, turn it into YAML, and then use your tooling to, to show the semantics of it as an envelope in YAML.
So if it might not even be an hour of your time, if you went to the use cases, which is on our new developer web pages, there's a envelope use cases for educational credentials that has some very simple Gordian envelope-ish credentials, and just pick one of those examples and turn it into a YAML prototype so we can have a better view of it.
Or at least take it to CBOR, parse it, and then see what you get out as YAML. I'd be curious to see what an envelope looks like just parsed as raw YAML.
So I mean, well, just one other comment on the tags. Like the tags can have structure in them as well. So if you wanted to make the tags URIs and then take advantage of the URI structure for path and query and fragment, you can put a lot of complexity in the tag. So it might look like in the example that I showed, it's just like a exclamation mark SD, but that tag could have been a lot of other structure if you wanted to create a standard way of encoding CBOR metadata in a YAML tag. For example, like you could probably get all of the semantic annotation that you are exploiting in CBOR out and into YAML in a bidirectionally lossless manner. And there might be something there, but I'm kind of new to all of this YAML work and only recently got this piece to sort of fit together. And so before I go spending a bunch of time on YAML, I thought I would share it around with other people and see like if you've done this before, or like what are the issues with it.
I think the main benefit I'm seeing is the ability to totally round trip at a higher level than just raw CBOR with envelopes, because that's not something that's been a goal for us for our other formats. They're strictly diagnostic formats, but for people to be able to write an envelope in text format and have it parsed, then YAML seems to be like that might be the right approach because of the higher level tooling that you're describing. But obviously how much resources we can devote to this in the short term, it depends on a number of things, which Christopher knows better than me.
Yeah, I think the key thing is if you can just another hour of your time to kind of take one of those examples and rough cut what it might be.
Okay.
I sent over a URL for where all of our use cases are, but those are the envelope use cases where I think Wolf was suggesting looking at the CBOR diagnostics.
Yeah. So and looks like, so look, you have to go to these links to actually see what they are. Yeah. So, and if you need any
educational one real quick.
Let's see, is that
the very first one, Wolf? Yeah.
Okay. So this one.
Yeah, I'd say the restrictor revelations or any one of those, but
right. So so this is envelope notation. So that wouldn't be parsable. This is obviously the mermaid notation, which is also not parsable. Why it's not scrolling? That's okay. And then so
I just put through the chat one of the files I used to create some of these.
Right. This is tree notation, which shows the hashes at every level.
Yeah.
And then the actual, but what you want is either the raw CBOR hex, or, let's see. So yeah,
Which it might be your envelope CLI docs would be better, because I think you have examples in there. And I also
I see.
just uploaded some use cases, how I created the data use cases, which shows all of the code to actually create them with envelope.
Okay. Yeah. So anyway, so if you need any, if you're curious to experiment and you need any assets, just reach out to me and I'll make sure, we can get together, get you whatever you need to experiment with. Because again, envelopes are just CBOR, but they have a specific semantic structure, and that's hierarchical. And so that I'd be very curious to see, whether that has legs in terms of, easy to implement. I mean, I think it might be, but I'm not sure.
And Ori, it seems plausible. I mean, it's one of the things where, if we nail it early, given some of the stuff that's going on with SD-JOT and COSE stuff, et cetera, that, it might help, build a bridge or even better, a wedge to get some of the people to look at the elision capabilities of these things more, which in some ways I care more about that than the pure Gordian. I just want, we need to be doing elision more. So period. Let's move on. I think we just have a couple more slides. I think the key point of our slides here is that our DCBOR libraries are in Rust. They're solid, they work, they've been through a number of iterations. We have an internet spec associated with it. And these are our first Rust libraries. Everything we've done before was in C or Swift. So we're really needing community review of our libraries as far as, are we presenting the right APIs that solve your needs? Does it address all the functionality that you need, or do you need some kind of higher level of functionality with it, et cetera? And then if you're a Rust expert, are we doing the idioms of Rust in a way that you expect? And we're going to be doing more and more Rust coming out in the next few months, including, it is our goal by the end of the year to have our entire CLI stack Rust version of the whole thing.
Right. So you can just pull down a crate, tell it to create it, and then you'll have essentially the envelope command line tool that currently is written in Swift and only runs on Macs, but you'll have it anywhere in Rust.
So anyhow, we need community review. Once we get past community review of some level, then we can justify the expense of having a formal security review of some of these code libraries, which would, is basically paying an independent third party to review them. Next slide. So yeah, our next Gordian meeting is October 4th. One of the big questions is, what is going to get us the best participation? We have wallet vendors on, in Europe and in Asia, but I think, I don't know, we just need to make some decisions. There is a discussion in the Gordian discussions GitHub about this. So, maybe start with a poll of, I can't do the Asia time zone things, or, oh, I'm in California, I can do both, or I can't do the Europe ones. So we just simply have a better understanding of who is coming to October 4th meeting, and so we can schedule it. What's the URL? Oh, is that link to the,
Yes.
yeah, the Europe or Asia. Okay, and I think that's it. Obviously, all these resources are at blockchaincommons.com. I believe that we are recording now. We'll probably break this recording up into little pieces and put up on YouTube. So please share. Any final? We didn't hear much from Thunder Biscuit. Is there anything you want to help us close with at the end today?
Nope, nothing in particular. I had prepared some comments. I spent a bit of time last week trying to build a Kotlin multi-platform version of UR.
Oh,
And
okay.
I've written some comments, so I'm happy to talk about that more informally after you stop it, or I can talk about it now, whatever you guys want.
How are you doing on time for just a little, could be just a little bit, another video we can add to the end. So Wolf, are you okay?
Yeah, I'm okay for a few more minutes. I'll need a bio break soon, but yeah.
Okay, so why don't
Do you want to share your screen?
Yeah. Sorry, I don't have a screen share for this. I have
If you want to set a link up, I can open the link and then share my screen.
Yep. Okay, let's do that. Sorry, I should have prepared. This was 3 or 4, maybe 2 or 3 days, I should say, where I was trying to get the PSBT working so I could exchange signed PSBTs between hardware device and some of our example apps for the Bitcoin development kit.
Which, by the way, that's all in Rust, Wolf. So
Mm-hmm.
The Bitcoin development kit is in Rust, yeah. But my expertise is on Android, so I work at more the Android layer, although I manage the language bindings for BDK, which, by the way, there's a bunch. I think we're at 7 sort of like Bitcoin related libraries that are using Unify, which is a Mozilla maintained projects to generate language bindings from Rust code. So, and I'm starting a sort of community practice group that might meet once a month to discuss language bindings, because we're all using it at different levels, not with the latest necessarily Unify, and they've introduced like async future support, so we'll be digging into that. Some libraries are not as far as we are, and I maintain templates and documentation for that. So if ever that's something you're interested in, happy to get into that.
we're currently doing C, C++, Swift, and now Rust. Just as a proof of concept in a non-strong typing language, we also did a probably not ultimately supported, but currently it's complete TypeScript version of DC board. But back to the point, I don't think we have a lot of tooling to make bindings easier and testing all of that easier.
And by the way, I'm using the URRS implementation as part of our stack. I've just put a shim on top of it to give it some of the APIs that are more similar to my Swift stack. So if you look at the blockchain commons Rust UR library is not that. It's basically just a shim on top of URRS. We don't have our own native UR reference implementation yet in Rust, but we haven't needed it because the community has stepped up.
Yeah, that's awesome. I noticed that the Rust implementation is some of the beefier, like really beautiful inline documentation, which was helpful because maybe that's one of the things I initially found was that the research papers felt like a spec, but didn't have everything I needed to start coding it directly. But it recommended that I look up the Swift code and the Hummingbird. I'm a Kotlin developer, so I'm familiar with Java. So I had sort of like both on different screens. And some of the Swift, if you chuck into ChatGPT, it kind of like lets you know what's going on and can help you out a little bit. So that was pretty good. But one of the
pair programming with GPT now.
Yeah, it was helpful. It made actually a bunch of mistakes that threw me for a loop for a little bit at some point. But the first thing I thought I'd mention was that because there's no inline documentation, initially that threw me off. And it's the same for Hummingbird. He doesn't have any inline docs, so you either have to understand what's going on or patch it with the spec. But
usually what I recommend for third parties implementing UR is currently go through the unit tests one by one, because they're actually in an order of dependencies and complexity. So if you implement them from bottom up, then you'll get the whole implementation by the time you've gone all the tests passing.
I like it. Maybe that's the way to do it. It's just tests. So that was, but it worked out. And the Rust, of course, implementation has beautiful inline documentation. So I was always reading that and sort of cross-checking. I'm writing inline docs as well, so hopefully will help the next guys. So some of the things I ran into for me, yeah, the fact that the spec was broken into several pieces that were all research papers, but in a repo that has a much more than just the research paper for UR, threw me in for a loop. I had to sort of dig for them, and then, for example, because I didn't have a full picture of it, I wasn't sure if some of the questions I had were answered in further research papers or if they were just missing in the original one. For example, I didn't understand why. What the extra parts that were helping, for example, the shuffling is happening and then you provide extra parts for the UR. The reason why you want to have this is not necessarily explored in the research paper. So I have it, but I don't necessarily know what it does.
And by the way, since I'm on Signal all the time, feel free to reach out to me directly whenever you have questions like this. I'm of course I'm in the Gordian groups, but you can reach out to me one-to-one and just ask questions anytime. And part of why the docs are the way they are is because we were solving problems in certain sequences. Like, for example, how do you encode things efficiently for QR codes for air gap transmission? How do you generalize that? Oh, well, now what do you do if you want to actually break it up into into a series of fountain codes, and so on. So there's definitely been some, layers of abstraction we've added over time, and those have ended up in separate documents. But you're right. I mean, at some point we need to unify these things and bring them all together. But there's certain parts that are separatable that, like bytewords is a separate kind of spec. It basically is used by UR, but it's not UR. It's a separate thing.
Also, I will say that the intent is that things move from research to the WIPS folder, the wallet improvement folder, as once there are libraries. And but I think that was a great intent, and we just haven't done that. So that is one of the, now that we have the developer website up, rather than having it all in GitHub, is one of the things we want to do is, okay, like, what would it take to turn this into a BIP? And that means we would have to have bits of a bunch of different specs in one. And in some cases, like bytewords, we can reference bytewords, but we may only need two long paragraphs to describe exactly what bytewords does, purely from the perspective of to implement a PSBT in a BIP, rather than the whole thing of, oh, well, the long form of bytewords is useful for these types of things and all that kind of stuff. Which
the problem is still wanting a single source of truth for each piece of information, and just using cross references, which is obviously in some ways the best practice. Denormalizing things all into one document has its own advantages as well as disadvantages in terms of getting out of sync.
Yeah,
well, that's definitely
the website. I can see that the website you showed just now, like an hour.
Developer docs, yep.
Maybe getting at that issue, it's okay that it stays in different documents, but wrapping it up into pieces that are like, I think makes a lot of sense. So I'll be taking
definitely all credit to Shannon for that. He's been putting a lot of hard work into kind of creating a roadmap for people.
Cool. Yeah, so that's kind of what it is for Kotlin multi-platform specifically. I have some other issues that I'll be dealing with. In some cases, it's I need a specific, I can't use Java directly because Java doesn't, you can't target the Kotlin target for native. You can't use Java code, so it has to be Kotlin multi-platform, or you provide a Java and a Swift implementation for some of these things. So I think that that's what I'll be doing, for example, for the XO Shira 256 ***, something I have like.
So I say Zoshiro. I just call it Zoshiro or Zoshiro 256. If you want to be really, specific, you say ** after it.
Well, I found out this is a bug I chased for like 20 minutes or half an hour, but I found out there's a plus implementation. There's a plus version and a star. So
And we're using star star. Yeah.
Java 17 comes with the plus, but not the star.
Okay.
So that was one of my other questions. Was I felt like there's probably a reason, and it's not necessarily explored in the paper, but I felt like it was odd to me to just like, I took Hummingbird and I grabbed his Java implementation, and I copy pasted it and it worked, but I wasn't sure why this couldn't be maybe pulled out of some standard library, or if there was another way to rely on something I trusted more than just a random guy on the internet that just copy pasted his code.
Well, I can't speak to
Random
Hummingbird's
example.
choices, but I know that in my case, I found a lot of test vectors and made sure that all my things pass those test vectors. So so when I have implemented these things on my own, I'm really anal about making sure they pass all the test vectors.
Yeah, definitely. I think at some point, it's a worthy discussion, especially with maybe starting with DC bore, of a walk through of, okay, here's how you would port DC bore, but if this applies to all of our other libraries, here is the tests. Let's one by one implement each of these tests in a new language, and just sort of point out that that's generally how you approach things when you're writing, and how in general people can help. I mean, I would really love, Kotlin is definitely one of our other targets. So I would love to see a Kotlin version of DC bore, for instance, which will be useful for envelope. I mean, that's also another thing. It's kind of, you're implementing PSBT, which obviously there's, 13, 14 wallets at this point that implement that air gapped. But all of those wallets do it without crypto envelope. And you can go, well, why would I want to do crypto envelope? Well, the reason why is crypto envelope also can support crypto request. And that's something that can add a lot of value to PSBT, especially when it's multi-sig. So it's one thing when, I'm got a Sparrow coordinator and I've got my foundation devices and I can quickly do bap, bap, I'm done, okay? It's, I have control of the process. I initiate the process. It does things. But as soon as I have a foundation devices and some other wallet for a personal multi-sig, or Ori is off in the corner and is my emergency person, coordinating like what are all the features and the different subsections of Sparrow and all these different types of things becomes very hard. So one of the cool things about crypto envelope with crypto request and response is that you can basically embody the process in that first QR code. So you can basically say, hey, I need a public key to add to a descriptor.
It's not even just the ability to add metadata in general to anything, and then to elide it and all those other things if you want. It's basically the power of envelope. And yeah.
And so far, none of the PSBT. Now that they've got basic PSBT working, we really haven't had much buy-in of the next level. And I think it's because multisig has not been as broadly deployed as people think it has. I think people are still struggling with multisig. And, Shannon did a really wonderful scenario with, what was it, Sparrow as the coordinator, foundation devices as one signer. What was the other signer?
Gordian seed.
Gordian seed. And an offline key. And, on Steel. And it turns out that all the little twiddly bits that you have to configure in each app, you get rid of 80% of them just by simply saying, hey, I want to initiate a process, and just having it, do the right thing. And, but we don't have anybody who is ready to implement that yet. So if some people who want to actually do this kind of right and kind of extend it so it'll make multi-sig a lot easier. And in particular, also the other half of the equation is, where in heck do I get that XPub for that multi-sig that from somebody else, which nobody has done in a graceful way. I'd love, we'd love to have some help with that. So,
I have a
I'd
hard
also-
stop coming up here in just a second. So
I'd also take a step back and say we should figure out a way to flag trusted libraries, because the Hummingbird library you were talking about is by Craig Raw, who's a member of this community. And I don't think we've ever done unit tests against it, but I think it's probably one of the UR libraries we feel best about beyond our own. So we should figure out a way we can flag that sort of thing so that when you're doing an implementation, yeah, that one's probably good.
okay. Well, thank you much.
thank you, Thunder Biscuit.
And we hope to see more, report from you maybe at our next meeting or the next meeting in your time zone about your progress. And of course, please use either the Gordian community signal or Signal Wolf directly if you run into a specific problem.
Yeah, if you're ever scratching your head about where something is, just reach out to me. I mean, I don't mind at all. That's what I'm there for. So thank you, Ori. Thank you, E, for your contributions.
Awesome. Thanks. Bye.
Thanks.
Thank you, everyone.
Bye, everybody.
So we'll